Welcome to lesson 3.2, use parallel lines and transversals. So in this lesson, we are going to look at a special relationship between parallel lines and transversals that give us a few different theorems and postulates. So we'll begin with postulate 15, and postulate 15 is a corresponding angle postulate. So what it states is if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So any set of corresponding angles are congruent when they're along a transversal that's cutting parallel lines. Then we have theorem 3.1, the alternate interior angles theorem. And the alternate interior angles theorem is again dealing with parallel lines being cut by a transversal. So if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Then we have 3.2. And theorem 3.2 is the alternate exterior angles theorem, which says if two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. So now, based on that one postulate and two theorems, we know when we're dealing with parallel lines and a transversal that corresponding alternate interior and alternate exterior angles are all congruent. Then we have theorem 3.3, the consecutive interior angles theorem. And the consecutive interior angles theorem says if two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. So they add to 180 degrees. So example 1 says find the angle measure, tell which postulate or theorem you use. So got shifted over there. So we're saying what the angle measure is and then which postulate or theorem is being used. So all based on this image over here. So in part A, if angle 1 is 50 degrees, then angle 5 is also 50 degrees. We're using this transversal, and we see 1 is in the upper left of this intersection. 5 is in the upper left of this intersection. We know that these two lines here and here are parallel. What tells us those are parallel lines is it's hard to see on this diagram, but these little dark arrows, a single arrow on this line and this line, tell me that these two lines are parallel. So I know I have parallel lines. 1 and 5 are corresponding angles, so they're both 50 degrees. Part B. Angle 4 is 45 degrees. Angle 6, so 4 and 6 are right here. They are on the same side of the interior, so they're consecutive interior angles, which are supplementary. So they add to 180 degrees. So 180 minus 45 gives me 135 degrees for angle 6. In part C, if angle 2 is 130 degrees, then angle 7 is also 130 degrees. They are alternate exterior angles. 2 is here, 7's down here on the exterior of our two parallel lines, alternate sides. And then if angle 6 is 123 degrees, angle 3 is also 123 degrees. And we know that because they are alternate interior angles, 3 and 6 on the alternate interior side of these two parallel lines. Then example 2 says find the measure of angle 1 and 2 in each of the drawings. So in A, we know we have 120 degrees right here. So we're looking at this transversal and these two parallel lines. We know they're parallel because of the marking right here. So then I know 120 degrees corresponds with angle 2. They're both on the upper left of the transversal, so they're corresponding angles. Corresponding angles are congruent, 120 degrees. I also know angle 1 is an alternate exterior angle to the 120 degrees, so it is also congruent, or 120 degrees. And then we also could use vertical angles in this case for 1 and 2. 1 and 2 are vertical angles, so they're also congruent. Another way to know they're both 120 degrees. Then we're dealing with part B. We have 56 degrees here, so 56 degrees is a vertical angle to angle 1 here. So angle 1 is also 56 degrees. Or if I wanted to, I could figure out that angle 2 is a corresponding angle to 56 degrees, telling me angle 2 is 56. And then I could say that angle 2 and 1 are alternate exterior angles, making one 56 degrees as well. And then in part C, we have 108 degrees right here. 108 degrees corresponds with angle 1. They're both in the bottom right along this transversal, so they are both 108 degrees. Then I know that angle 2 and angle 108 degrees make a linear pair. In this case, right there, make a flat line or 180 degrees. So linear pairs add up to 180. So 180 minus the 108 gave me angle 2, which is 72 degrees. I also could figure that out, that 1 is a vertical angle to the missing one here, so this is 108. And then 108 and 2 are consecutive interior angles, meaning they add to 180. So then again, 180 minus 108 gives me 72. So as you can see, there's a few different ways to look at each of these relationships. You could use vertical angles and linear pairs, as well as our new theorems and postulate up here. Then we have example 3, which says find the value of x. So we have part A and B here. In part A, we have 75 plus 5x minus 10 equals 180 degrees. So how did we get that? Well, we got that from looking at this image here. We know these are our parallel lines. Here's our transversal. So these two angles are consecutive interior angles, meaning they are supplementary, so we can add them together and they equal 180. So the 75 degrees plus the 5x minus 10 equals the 180 degrees. Simplify our left-hand side. 75 minus the 10 gave me the 65, so 5x plus 65 equals 180. Subtract 65 from each side. 5x equals 115. Divide by 5, and x is 23. And then in part B, we have 92 degrees up here, 2x minus 4 down here. These two angles are alternate exterior angles, meaning they are congruent or equal to each other. So I can say that 2x minus 4 equals 92. Add the 4 to each side, 2x equals 96. Divide both sides by 2, and x would equal 48. And then in example 4, we're going to complete the 2-column proof. So I'm skipping part C from the previous example. Mine got misformatted and C got shifted down here. So I'm just going to skip that one, only doing A and B up here. So just cross that one off. And we're going to look at our proof. So we have our given statement and our prove statement. They gave us all the statements on the left. We need to provide all the reasons or justifications on the right. So our given information was that P is perpendicular to Q. The upside down capital T symbol is perpendicular. So we were given P is perpendicular to Q and Q is parallel to R. Two vertical segments next to each other indicates parallel. So we know Q and R are parallel to each other, given in the symbols as well, and P is perpendicular to Q, given by the right angle symbol here. So I can begin the two-column proof, P perpendicular to Q. That was part of our given statement, P perpendicular to Q. Angle 1 is a right angle. That comes from the definition that perpendicular lines form right angles. So that could be the definition of perpendicular lines or the perpendicular line theorem. Then we can say the measure of angle 1 equals 90 degrees, because if angle 1 is a right angle, by definition of right angles, its measure is 90 degrees. Then line Q is parallel to line R is part of the given information as well. They split it off. You could leave it up here. They split it here just for the order they were going through this proof. Because again, each step we're trying to get one step closer to proving that line P is perpendicular to R. So then they said that angle 1 is congruent to angle 2. 1 and 2 are corresponding angles. So the corresponding angle postulate allows us to say angle 1 is congruent to angle 2. Then, if they are congruent angles, by definition, their measures are equal. So the measure of angle 1 equals the measure of angle 2 by the definition of congruent angles. Then, measure of angle 2 equals 90 degrees. That is a substitution property, or could also be the transitive property. Either one would work. But if the measure of angle 1 is 90 degrees, and the measure of angle 1 equals the measure of angle 2, then the measure of angle 2 is also 90 degrees. So either way, the substitution property or transitive property. And then we have angle 2 is a right angle. So if the measure of angle 2 is 90 degrees, by definition of a right angle, angle 2 is a right angle. So they can make that statement based on the definition of a right angle. And then finally, because we now know angle 2 is a right angle, P and R meet at a right angle, angle 2. So P is perpendicular to R based on that definition of perpendicular lines, or the perpendicular line theorem, that perpendicular lines form right angles. Then we have example 5. Example 5 says prove that if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Well, we know that from the alternate interior angle theorem. So we are proving the alternate interior angle theorem. Remember, theorems can be proved or are proven. So in this case, our conclusions on the left, justifications on the right, or statements on the left, reasons on the right. Conclusions and statements are interchangeable. Reasons and justifications are interchangeable. So they might call it statements, reasons. They might call it conclusions, justifications. So in this case, the first thing I do is draw an image if I don't have it. So I just drew an image with two parallel lines. I labeled them P and Q. And then I had a transversal labeled line T. And what I'm trying to do is prove that alternate interior angles are congruent. So I just numbered my alternate interior angles, 1 and 2. And then I also numbered a third angle down here, 3. So now I can start to work my way through my proof. Well, what was given is that I'm dealing with two parallel lines, so I can be given that line P and Q are parallel. Then I use angle 1 and angle 3 if I know P and Q are parallel cut by a transversal. 1 and 3 are corresponding angles. So by the corresponding angle postulate, I can state the conclusion that angle 1 is congruent to angle 3. Then I can also state that angle 3 is congruent to angle 2. That I can state based on the fact that vertical angles are congruent, so the vertical angle congruence theorem from our previous lesson. And then I also can state that angle 1 is then congruent to angle 2. And the way that I can state that is if I know 1 is congruent to 3 and 3 is congruent to 2, I can drop that angle 3, the repeated part, and state that angle 1 is congruent to 2 from the transitive property of congruence. So using some postulates, theorems, and properties, we can prove our alternate interior angle theorem, or the alternate interior angle postulate, alternate interior angle theorem, I should say, theorem 3.1. Down here, this would be our proof for that theorem. So again, as you go through the practice problems, this new postulate and these three theorems create many different ways that we can use these angle pair relationships to help support reasoning and proofs, as well as figuring out different angle measures in diagrams.